Find the limit. The limit e to the 2t minus 1 over sine of t as t approaches 0. If we try the quotient rule here, we would be asking what is the limit of e to the 2t minus 1 as t goes to 0 divided by the limit of sine of t as t approaches 0. Both the numerator and denominator are continuous functions, so we can calculate the limit by substituting in the 0. So we would get e to the 2 times 0 minus 1 over sine of 0. 2 times 0 is 0. E to the 0 is 1, so this would be 1 minus 1, and the sine of 0 is 0. So we do find that we have an indeterminate form, 0 over 0. So actually this would tell us that the quotient rule fails. However, there's still some hope that this limit may exist. And one method that we can employ here is LHopital's rule. Notice that there's no way that we would be able to cancel that sine of t from the denominator in order to get rid of this 0 in the denominator. So we really do have to rely on LHopital's rule and hope that we can evaluate this limit properly that way. LHopital's rule says you take the limit, in this case as t goes to 0, of the derivative of the numerator divided by the derivative of the denominator. The derivative of the numerator is 2e to the 2t. The derivative of the denominator is cosine of t. Now when we try LHopital's rule, the quotient rule, we're taking the limit of 2e to the 2t as t goes to 0, divided by the limit of cosine of t as t goes to 0. Again, the numerator and denominator are both continuous, so we can simply substitute in the 0 to calculate their limits. E to the 0 is 1. 1 times 2 is 2. The cosine of 0 is 1. So we actually find out that our limit is equal to 2, and we've used LHopital's rule to get there.